So, myself is Sagar, and I'll be going over the session today on understanding the webinar and on design patterns. Basically, today we are going to understand what is use of design patterns and why we need to use design patterns. What are the advantages of using design patterns, right? Why design patterns is really required in existing technologies, right? And I have more than decade years of experience, and also prior to this, I have been training in Edureka for almost more than a year of time. Sorry, almost more than 1 year of time with Edureka, and prior to that also I have been part of different other trainings too. So this particular webinar is coming to you from Edureka. I think most of you will be aware of what Edureka is all about. So we are one of the global online training providers, right? So and means we provide training across different technologies and some technologies like Hadoop, etc. Also all large scale training and with online support for 24/7 support we provide. Okay. And yeah, so with this introduction, let's go and look into today's session. So today's session, as we discussed, basically we are going to concentrate on understanding of the design patterns. Okay, why we require design patterns, and let me first of all explain you why we require design pattern. Then we can go and look into the different aspects of design pattern. So design pattern is one of the most fundamental things in any programming language, right? So the main aspect of coming up with design patterns is to make sure the code reusability is done to a good extent, right? So this code reusability in the sense, so in most of our things, so what happens? So let's consider as an example, we might work in an organization. Let's consider a mobile organization, right? And we might try to develop we might have different series of mobile. Let's say we released a mobile on C series with some functionality. Now we need to come up with another mobile which is almost going to take the functionality of the C series, and it's going to provide some extra functionality on top of that, right? Some other extra functionality. So this combination becomes next level of series called as D series. Now the biggest question here it will be that can I reuse the code which is already part of the C series, or I need to again write everything from the scratch, right? So technically, if you are going to write everything from the scratch again, probably it's going to end up in a longer period of time to develop the code. Fine. So this is where design patterns everything comes up in the picture. How I can reuse how can I reuse the code very much effectively which has been used for some other development. So in such a way it's going to be extendable, right? So making your particular code extendable, right? So all those things is coming up as part of your design patterns technology. So design patterns is basically some of the principles or the design techniques which followed to achieve code reusability, extendability, etc., and lot of different aspects, right? So these are some of the fundamental things which we never do in our programming. Okay, we do program, we develop a lot of things, but most of the time we end up redoing the code again and again, right? So we always end up redoing the things. So that's what basically we do, right? So we might have the release one, we have a release two, we have a release three, but if you see in all the different releases of the code which we have done, probably what happens, there is no reusability will be there. It's very rarely we might have reused. Instead of reusing, we always redo, correct? We end up redoing the stuff again and again most of the times. So what are the aspects of the code one should be aware of while writing it? Okay, what are the principles should be followed, right? So that's what we are going to discuss today. Basically the design patterns is extremely huge. The design patterns itself, there are a wide variety of design patterns is available in the market today. It means it's extremely huge. It's not like you can define only 10 or 15 principles, right? So there are a lot of principles is available. So we are going, it's that's what the complete course is all about, providing you a complete overview or insight on what design patterns is all about and why you require design pattern. So that's the main intention of the course, right? So, but since we have a very less time constraint, so we are going to look only some of the most widely used design patterns, right? So we have picked up some of the most widely used design patterns for this particular session, and also I will go through each and every use case, explaining you how this can be effectively used, etc. All those kind of things, with each and everything with an example. Okay, almost with each and everything with an example. And once it is done, so next level of thing what we can do is that understand the complete sections of the patterns which is provided as part of the course too. So in that order, let's take one pattern at a time. So let me go over one of the pattern. Okay, the first pattern which I'm going to discuss is something called as an adapter pattern, right? So this pattern basically comes up a very interesting pattern. So as the name adapter suggests, it's like so for an instance, even before going to the code, right? Just to provide you an understanding of what adapter pattern is all about. So you might have bought a particular laptop or a mobile in USA, right? And you probably like will be trying to use it in India or in some other country. So mostly what happens, the socket which has been used for USA, right? You cannot use the same socket for India, right? So that's what basically technically happens. Okay, just give me a minute, everybody. So basically, what happens when you try to buy a corresponding laptop which is made in another country called an USA, right? So if you buy a laptop or a mobile which has been bought in USA, and you are a mobile or laptop, and you are basically trying to use the same thing in some other country like India, you can't use, probably you can never use. The primary reason is the socket in USA is different compared to India. So this is a very straightforward scenario, right? So what is the ultimate solution for this? The ultimate solution for this is neither we can't change the laptop pin, right? We cannot change how the socket structure is in India, so we can't change the physical things. When we talk on the physical things means the socket which is available in Indian portal compared to the socket which is available in the USA side, right? So these both cannot be done at any angles. You can't do anything. So probably the best solution is to come in with an adapter. So when you say come up with an adapter, so like this, which has been shown in the diagram, right? Come up with an adapter where it supports their corresponding sockets, right? So all you have to do is that you have to buy an adapter and you have to start plugging your corresponding switches using that adapter. The same way when coming to the programming. So let's say I have the same situation, right? I have a situation where I have a client who is using code for 10 years. Let's consider I have a client who basically using my code for 10 years. Now all of a sudden what happens, there is a requirement comes up, or let's say a code which has been used for last 10 years is outdated. It has become outdated, right? Some of the functionalities, not the complete code. Maybe the code might have some 100 classes. In this, some one or two functions, right? Maybe a particular class might have become outdated, or we have to update to the latest technology. So if that kind of scenario comes, right, where I need to update myself to the latest technology or whatever it is. So now the biggest question is, can I go ahead and change the code directly? Right. If I do this, what will happen? So if I do this, what will happen? The first biggest question I need to answer is, if I change the code directly, the code is already servicing my client for 10 years, right? So if I'm going to change the code directly, what happens to the support which is already being provided? Is this going to take a hit? How we are going to handle that scenario? This is first question, right? And second thing is, if I change the code, whether it will function in the same way how it is functioning for last 10 years. So likewise, we need to answer lot of questions. So if probably when you want to try to change the code in the production or some environment, so basically what happens, you need to come up with a solution, right? So you cannot change the code directly. It's not possible because the code is already serving the corresponding customer or the corresponding functionality for almost 10 years now. So if you're trying to change, you have to make sure two things always in sync. What are the two things? The first thing is the code which you are going to change has to make sure it is not affecting the current customers because they are already using it. The second thing, the, the newly added code should always be in a position of, okay, the newly code should be always in the position of supporting whatever it is already doing. It should not come back and say, so for an instance, if I add a new code, it can support all the new functionalities, but at the same time it should also support the old functionalities. Okay, so two things I have to make sure. One is the code, the code change should support new functionality as well as the old functionality. Okay, second thing is it should never affect the current customers, right? Because they are also scale support. So how can I achieve this? I have to change the code. If I change the code, it should support new functionality as well as old functionality, and also you should never affect the current customer status, right? So I have to achieve two things at the same time, right? So what is the best solution for me? So the best solution is to come up with an adapter where we are not even touching the current code and providing the new solution to. So that's what probably the best solution we are going to do, right? So if I add a class A, if that class A is basically, if that particular class A is now supporting, and maybe it's supporting the production for 10 years or 15 years, etc. down the line. So probably what's the solution we are going to provide is, we are not going to touch this class A. Instead we are going to write the plugin. Okay, all the new code will go and do here. Okay, so this plugin will act as an adapter to class A. So basically by doing this particular approach, okay, so by doing this particular approach, what's going to happen is we are not touching our current code, so that all the customers is going to be the same way. At the same time, what we are going to do is that we are also going to make sure the new functionality is supported. So that's why basically adapter pattern comes up. So when you look back into the code, so I'll just take an adapter pattern. So if you look back at this corresponding code, so see here, so this is a code which has been used for some period of time. Now, if you look back in this particular code, what happens? We use something called as an enumeration. Okay, for the Java guys, you can understand this code. For the non-Java people, just you can understand what is the functionality we are trying to achieve. So here, what I need to do is, now this has been keep using for some period of time. Now, all of a sudden, what happens? I just want to, okay, change this particular, okay, means this enumeration which has been supported here, right? So I want to change this enumeration to one of the latest technology. The latest technology is iterator, right? Now the thing, as we already discussed, I cannot change the code, right? If I change the code directly, so what's basically going to happen is uh, this is going to get affected, and all the customers who are using this probably is going to get affected. At the same time, I have to provide the new functionality. The new functionality is iterator. So I just want to change this enumeration to iterator. At the same time, I should not touch the code. So what basically I'm trying to achieve is, you can see here, I'm leaving the code as it is. Okay, I'm just writing an adapter. So in that adapter, what I'm trying to do is very simple thing. Wherever you are using enumeration, you are still going to use enumeration, but the methods of enumeration, right, internally are going to provide the iterator logic. right? So you are still going to use enumeration. There is no change in the way how we use enumeration. Everything is going to remain same as it is. But what we smartly do is that the methods of enumeration now internally started providing all the new things what iterator does. So this is what basically adapter pattern is all about. Okay, so so that's what basically adapter pattern does. So in this particular scenario, basically what happens is you still use enumeration, but you are calling the for instance what happens. These are the enumeration methods. The enumeration methods is what. So let me take up here. I have an enumeration. So this enumeration is having method called as next and next. Okay. So my client is using this enumeration for some period of time. This we already know, right? The client is using enumeration for some period of time, and the client code is still calling as next and next. But what I'm trying to do, I'm having an adapter. What an adapter does, now the corresponding as next and next method will provide internally the implementation of iterator. Okay, so internally it will provide the implementation of the iterator. So by doing this, basically what happens is the client still uses enumeration. The client is still using the as next and next method, but smartly what we have done is the implementation of the enumeration is basically now is going to provide me the iterator logic, right? So by doing this, what happens? The code is never changed. Everything remains as it is. The client is still getting the same response. There's nothing big major change has happened, but at the same time one also has to understand that I am now getting the iterator logic without even changing a very single code, right? So that is how the adapter pattern works out. So that's the advantage of using something called as an adapter pattern. Okay, so do you all getting an understanding of what adapter pattern is all about? Can I like a quick yes no everybody? Got an understanding of what is adapter pattern is all about? Yeah. So leave the current code as it is, and don't ever touch the current code. Instead of go and provide all your implementations in an adapter kind of perspective. So by doing this, basically what happens, you are always making sure you're also using the latest code. At the same time, you're also understanding only one thing is you have provided the current implementations. Okay, so that's the way you can achieve basically an adapter pattern. One of the most widely used patterns when you never want to change your current code or current context or current scenario, right? In all those kind of scenarios, one can always use your adapter pattern. So now coming back to next pattern. So let's go to next pattern like this. Let's take another pattern now. So like an adapter pattern, so basically now I'm going to take you to another pattern called as basically a decorator pattern. So again, a widely used means one of the again widely used patterns, right? Like your adapter pattern, we have something called as decorator pattern. So let me take an example of decorator pattern and explain you what decorator pattern is all about. So let me take up the example. So I'll go to the Eclipse now. So let's say I have a very interesting scenario. Okay, the scenario is straightforward. So so now let's see. I'm thinking the PowerPoint is nicely explained. Okay, so now as a user, okay, I'm giving you basically to make a beverage, right? Something like that. And the beverage should be of a dark roast, espresso, and cappuccino. But I'm just trying to ask you to make a beverage. So let's note down this option so that we can understand it better. So we are trying to basically do a beverage. and the beverage which we are trying to do is basically an option of dark roast, espresso and cappuccino, right? So these are the options of the beverages. Now, what happens is we are giving you three options. So we are asking the beverage to be done with mocha, milk and soy. So now what happens? So we have to make it in three flavors, one with mocha, one with milk, one with soy. So probably what's going to happen is that, so this is what basically going to end up. So you are going to make a dark roast with mocha, milk and soy, and basically you're going to create an espresso with mocha, milk and soy, and basically you will do a cappuccino with mocha, milk and soy, right? So these are the three. So you actually ended up doing 9 implementations. So this is what happens when you are not using design patterns and when you are not thinking of design patterns in your code. Now, with the help of decorator pattern, so basically what's going to happen is, see, what the decorator pattern suggests is that instead of having 9 different implementations, let's have a beverage and you have something called as, you have a cappuccino, you have a dark roast and decorator. Now, if you see the cappuccino and the dark roast and the decorator all extends beverage. So now basically what happens is, what smartly we are doing with the help of decorator design pattern, we are not looking as, instead of looking as a dark roast and espresso and cappuccino, we are telling all together should be looked as beverage. So now what happens, we are asking to make a beverage with mocha, milk and soy, instead of telling do for dark roast, do for espresso, do for cappuccino. So now from 9 implementations, basically we are now streamlining to 3 implementations, right? So that's what basically we are trying to do. So instead of doing from 9 implementations, basically we are trying to streamline to into 3 implementations, right? So that's what basically happens with the case of your decorator pattern, because by extending dark roast, espresso and cappuccino to beverage, we are treating them as one common beverage. So while implementation, if you say my beverage is dark roast, you will get dark roast with milk mocha soy, or if you say espresso, you will get an espresso milk soy, and if you say cappuccino, you'll get cappuccino milk soy. So by doing this, basically what happens, we are providing a dynamic option for the user to enter, whether it is of type dark roast, whether it is type of espresso, whether it is type of cappuccino. So we are not providing concrete implementations. So instead of providing a concrete implementation, instead of concrete, okay, we are providing common implementation. So that's what basically happens, right? Instead of providing a concrete implementation, we provide a common implementation, and we are basically trying to say that you have to consider for beverage instead of considering for the dark roast or espresso or cappuccino. Instead of considering all the three differently, let's consider everything in one shot. So by doing this, basically what happens, you end up doing only in one implementation instead of 9 implementations. So now when you see test the decorator pattern, basically what happens, I'm just telling beverage with espresso or beverage with soy. So when I'm doing something like this, There is no concrete implementation because all of the three are extending. Oh, sorry about this. Okay, fine. So now I'm able to execute it. Sorry about that. There were some issues in the JRE system library setup. So that's what basically happens with the help of your decorator pattern. So instead of providing different implementations, you can basically come up with one concrete implementations. So you can just look back into this in your real-time production system too. You might have really written code where you come up with one common implementation. That's the best strategy to follow. Instead, what you do is that basically you provide different implementations for different perspective, right? So which basically in a way basically increases the effort to a greater extent, so which should be streamlined. So when I say streamlined, provide only one particular common implementation which basically does all the other things, right? Can you show the test decorator? I can show your corner. This is a test decorator, which is now, if you see on the left hand side, it's always beverage. It's not basically we are trying to say whether it is of an espresso or etc., all those kind of things, primarily because the cappuccino and the dark roast and the decorator extends beverage, so we don't need to say that particular pattern to be followed. We have to say only beverage on the left hand side while creation, and you can say what type of beverage you want to create. Please show mocha, milk and soy. Sure, Ashok. I should. And one more thing, Ashok and Kunal, this code will be provided to you. Okay, please don't worry about this. Code will be provided to you. You can always go through the code. Fine, Ashok, Kunal. Ashok, is it fine, Ashok? This code and the corresponding PPTs will be provided to you also. Don't need to worry about that. So you can always debug and look back into the same. Is it fine, Ashok? No, Kunal. And what I'm trying to say is that the code will be provided to you, so don't need to worry about that. The code and the webinar both will be provided to you. That's what I'm trying to say, Kunal. Fine. Is it fine, Kunal? Can you hear us now or not? Can you confirm, Kunal, please? Yeah, fine. So what I was trying to say is that the code will be provided to you, so don't need to worry about that. We'll also provide the code to you. Okay, yeah. So let me also go through maybe one more design pattern called as change of request pattern, which is basically again used very widely uh, in most of the production systems. So for an instance, so let me go the chain of responsibility pattern. A chain of responsibility pattern is again one of the most widely used pattern. It is like chaining the responsibility from one section to another section. Okay, so that's what basically chain of responsibility pattern is all about. So let's consider a very real-time scenario. I have a BPO kind of perspective, right? So let me take out the BPO scenario. So if you go for a BPO scenario, basically what happens is, right, you have different kinds of support, L1, L2, L3 and L4. So what happens? Initially the call goes to L1. So if L1 is not able to support, then it will be bypassed to L2. And if L2 is not able to support, then it will go through L3. Correct. And if L3 is not able to support, then it will go to L4. So this is basically a chain of responsibility pattern where the responsibilities keep shifting from one section to another section, right? So basically we are keep on shifting the responsibility from one particular section to another section, right? L1 comes up, L1 is not supporting, then it goes to L2. L2 comes up, L2 is not supporting, then it goes to L3. And L3 comes up, not supporting, then it goes to L4, right? So if I want to implement the same thing, so this becomes a chain of responsibility. This is called a CO, a typical relation, right? So if you look back this, how this can be implemented is, so if you look back this, so what happens? I have an L1 support. So if this is the basically L1 support, the L1 support says these are the queries I'm going to handle. If user is firing a query like where can I download the file, how much time it will take, what is the fee? If this queries comes, he will handle. If the query is not matching this, then basically he's trying to say, I will push my handler to next support. Okay, he's not telling who's the next support. I will tell you why is the reason. He's telling the support will go to next support. So similarly, L2 is coming, right? L2 is again telling if the queries is matching this, how to run the project, how to create a mapping file, what should be installed, I will support. And if none of them is matching this, then I will provide the corresponding query to my next support. Again, he is also not telling who is his next support. Same thing goes with L3 and same thing goes with L4. So all of them are defining what are the queries they can handle, and if the particular query is matching, they are going to say yes, I am going to support this. If the query is not matching, they are pushing their thing to next support, right? So where this next support is basically declared. So when you come back to the main program, what we are trying to say is that we are trying to say, listen L1, if your corresponding handler is L2, right? So this is like something like an event delegation model. We are delegating our work to next person, right? So L2 we are telling your support is L3, L3 you are telling your support is L4. So basically by doing this, what happens is, or what we are trying to achieve by doing this particular kind of concept is, we are just delegating if we are not able to handle a particular query, right? So that's what basically happens. The next support is basically the corresponding handler which you are implementing, right? And you can basically go back and see the superclass what is extending to. The superclass is having basically the set handler. So when you say L1 dot set handler of L2, basically the next support. So see, when you say L1 dot set, let's go to the main program. When you say L1 dot set handler, so this it comes here. So what is the next support for him? Is next support is L2. So similarly, when you come to L2 support that set handler, basically his next support is coming to L3. So that's what basically going to happen. So declare an handler and keep on bypassing your request to next immediate level. So this can be effectively used in the real time where you have multiple if else condition, etc., all those kind of things, right? So this is run as Java application now. Oh, sorry, again I need to set the part for this. Sorry for this. I'll set it now. Sorry about it. I'll set it now. Just give me a minute. Sorry about that, everybody. I just rectified the corresponding Java build path error. Actually, I imported this corresponding project which is having the pattern of 1.6, so that's why when I re-import it again, I need to recouple again, right? So this is one of the effective way of handling multiple if-else conditions, right? If you are writing an hierarchy kind of thing, right, the manager-employee kind of relation kind of thing, so this particular thing will help you a lot, right? So these are some of the design patterns basically which we looped into today. Basically, when you come as part of the course, we'll be providing a lot of other design patterns. So I can just show you the corresponding course topics too. Okay, so did you all getting an understanding of, means the intention of this particular session is to, as I said, it's very difficult for me to go over the complete design patterns which is available, but just to give you an idea of how much effectively you can reuse your code, right? So basically, so you consider if there is no adapter pattern, you will be keep on outcoding the same thing again and again. And if there is no such a decorator pattern, you are re-implementing everything again and again. Okay, and if there is no such like chain of responsibility pattern, you never know how to bypass to the next level. Instead, you will be keep on outcoding a lot of different things, right? So when you basically join the course, right? So this is what basically the complete topics will be provided, right? So when you look back into this, we have introduction to design patterns, creational design patterns, structural, behavioral, concurrency, anti-patterns, refactoring. So like this, there are a lot of different things we'll be explaining as part of the course, right? So you can always join the course. It will be a very interesting course. You can join basically. Even I'll be also taking as part of this. I'll be explaining you the different design patterns which we are going to work on, and like this, we will take all the different use cases. We'll be going through this. Okay, so you can basically join it. You can contact the support team for the course details. What is the course price, etc. All those kind of things. We'll be in fact looking more than this kind of design patterns which is available. Okay, so I was is the today design pattern session helped you all getting an understanding of how much code can be see, it's the basic iteration of design patterns. Not only you should be a Java knowledge guy, right? It's just to tell you how much effectively you can rewrite your code, how much effectively you can reuse your code, Okay, that's what design pattern provides, right? So is this session help you a lot today? Can I get a quick response from you all? Yes, thanks everybody. So I request all you to go over the course details, course structure. So please get in touch with the Edureka team and Edureka support team. And also please you can mail me back at any point of time, any questions you have, I can just mail. I'll mention you what is the Edureka support mail ID now in the chat window. You can take a note of it. I'm just going to provide you now. So this is the corresponding email ID. This is the corresponding email ID where you can contact the Edureka support regarding the course details, course structure, etc. All those kind of things. And also you can any point of time contact me also. I'll provide my email ID too.